Okay, so I'm going to review the test. I know most of you guys did very poorly on this, so I'd like you to make sure that you're paying attention. A chemist has 2 blocks of sodium. The first block has a mass of 15 grams and a volume of 15.4 centimeters cubed. The second block is half the size of the first. What is the density of the second block? Now, what you need to remember is that density will always be the same no matter what the size of the block is. So whatever the density of this block is going to be the density of the second block. Because it's half the size, it has no effect on the density, because the density is a physical property that does not change when the size of the item changes. Okay, so 15 divided by 15.4, you should be able to do that sort of in your head. It's going to be pretty close, so it's almost 15 divided by 15, so it's in this. 15 is smaller than 15.4, so it won't be 1.03, it'll be 0.97. Okay, Shirley has 3 containers of different liquids. One container has vinegar, one has canola oil, the third has corn syrup. She measures the mass and volume of each substance and then pours each liquid into a beaker. Shortly thereafter, the liquids separate into layers. Here's Shirley's chart of observations. Okay, so you have to take a look and think, okay, these are the 3 layers. So the one with the greatest density is going to be on the bottom, and the one with the lowest density is going to be on top. Okay, you can do these in your head. 30 divided by 100 is going to be 0.3 grams per milliliter. 25 divided by 100 is going to be 0.25 grams per milliliter, and this one is going to be 0.55 grams per milliliter, which means the corn syrup is going to be on the bottom because it's the largest, followed by the vinegar, which is going to be in the middle, and the canola oil is going to be on top. Okay, so that's C. Canola oil will be on the top. Okay, number 3. Nick enjoys a drink that his babushka used to make for him when he was young called kvass. It is brewed from a delicious bread, blackcurrant leaves, yeast, and sugar. The ingredients are steeped in hot water, much like tea is steeped. The mixture is then strained over a glass through a filter. Okay, so you got all this stuff, and you put it in a filter, and you strain it into a glass. So all the stuff, the bread and everything's going to stay up here, and the liquid is going to come down here. Okay? And that liquid is going to be homogeneous, so it's going to be a solution. Okay, Olivia has 4 samples of white crystalline powder. By all outward appearances, the substances are identical. Her teacher insists, however, that all 4 substances are different. Which of the following would not help Olivia to determine what each substance is? Now, the substance, you need to remember the physical properties that can identify a substance. You can identify a substance by its density, by its melting point, and by its conductivity. You won't be able to identify it by its mass, because if you change the mass of a substance, it changes, it doesn't change what the substance is. If you change the density, it's going to be a different substance. If the melting point is different, it's going to be a different substance. So she couldn't tell which ones are by mass. And if you remember in the textbook, they had spoonfuls of different types of stuff. And if I have a spoonful of sugar and a spoonful of salt and a spoonful of baking powder, let's say, I can take my 4th unknown spoonful, we don't know what that one is, and I can say, well, if I figure out what the density is, I can compare it to the other ones and try and do it. If I figure out what the mass is, the mass of this one is not going to tell me that it's either of these. You can use either density, melting point, conductivity, you can use boiling point, all those features that will identify a substance. Okay, which of the following best describes why calcium chloride is a solid at room temperature while water is a liquid? Okay, what we need to remember is solid, liquid, gas. Okay, here's your melting point and here's your boiling point. So a liquid water is a liquid in between these two, right? And all substances are a liquid in between their melting point and boiling point. So let's take a look at calcium chloride. Actually, calcium chloride is a solid here at room temperature, which means it's going to be a liquid up here and a gas up here. So here's its melting point and boiling point. Okay, and you can see from this that the melting point of calcium chloride is much higher than the melting point of water. Okay, because water is a liquid at room temperature, whereas calcium chloride is a solid. So that's the answer. The subatomic particles whose activity mainly determines the charge on an atom are electrons. And it's only if you gain electrons or lose electrons you're going to change the charge of on an atom. None of these other ones change the charge of the atom. Okay, Madison brings chocolate chips to school every day to have a snack while she's waiting for her bus. One day it was exceptionally hot, and she left her lunchbox on the playground after lunch. When she picked it up after recess, she put it in her backpack until the end of school. When it was time to line up at the bus stop, she opened her bag of chocolate chips. They were no longer chips, but a large clump at the bottom of the bag. What is the reason her chocolate chips appeared so different? Okay, so you have to think that the chocolate melted, and then it cooled off again because it was hard. So we have to take a look. Did it reach the boiling point? No, I doubt it boiled because that would have been really hot. And then they reached the melting point, in which case they would have been liquid anyway. The chocolate reached the melting point. Yes, they melted and then warmed up. No, they probably cooled down. The chocolate warmed to the melting point. Yes, and then cooled. So they became a liquid and then cooled back to a solid. So it would be C. Okay, Lily and Haley were conducting an experiment. There were two liquids on the table. When they combined the two liquids, they noticed a number of things happening. The volume of the substance increased. Well, that makes sense if you combine two things. A precipitate formed. Gas bubbles arose on the surface. And the liquid changed from a bright red to a milky white. Which of the above does not provide evidence for a chemical change? Okay, so we know that a chemical change is when a gas forms. We have a color change and a precipitate. So let's take a look at these. Okay, number one, the volume of the substance increased. Okay, so that's a physical change. Precipitate form, that's a chemical change. Gas bubbles, chemical change. The liquid changed from a bright red to a milky white. That's a color change, so that's a chemical change. Okay, so it says which of the above does not provide evidence for a chemical change? That would be 1, the volume changed. Okay, in the table below, who has the item that is considered a substance? And don't forget, a substance is one that is uniform throughout, and it's always got the same stuff in it. Okay, now Coca-Cola does not always have the same stuff in it, because from one year to the next you might get more bubbles in it, or a little bit more soda in it, or whatever. Butter is not uniform. It's not always the same because different companies make butter differently. Milk is not always the same. It might have more milk fat in it one day and less milk fat. Glucose is always the same. It's always 6 carbons, 12 hydrogens, and 6 oxygens. Okay? There's a chemical formula for glucose, and so that's it. So Cristobal has the thing that is a substance. Okay, number 10, the chart below shows the subatomic particle count for 4 atoms. Which of the atoms is a positively charged cation? Okay, so if it's positively charged, that means the number of protons has to be greater than the number of electrons. Okay, so let's take a look. Protons 10, oh, those are equal, so it can't be that one. Protons 8, electrons 10. Oh, the protons is less than the number of electrons, so that would have to be negatively charged. They're equal, that's a neutral atom. Number of protons is 3, number of electrons is 2. So that means that atom is positively charged, so it's D. Okay. Anthony, Kevin, Taryn, and Jonathan went on a camping trip for July 4th. Each of them had a different task to make the trip enjoyable. Anthony was responsible for cooking, Kevin was responsible for making a fire, Taryn was responsible for boiling the water to be sure it was clean, and Jonathan was responsible for the fireworks display. Who has a task that did not involve a chemical change? Ooh, I forgot to put that. Thank you for not complaining about that. Okay, so a chemical change is one that is burning, cooking, rusting, and digesting. Okay, so let's take a look. Cooking, chemical change. Kevin was responsible for making a fire. Burning, chemical change. Taryn was responsible for boiling the water. Boiling water is a phase change. That's a physical change. To be sure it was clean. And Jonathan was responsible for fireworks. That's burning. So that's a chemical change. So Taryn is the one that had a task that did not involve a chemical change, because boiling water is just changing it from a liquid up to a gas. It's still water, it's water vapor at that point. So when you change the phase, you're not changing the substance. It's still water, but it's in the gas form. Okay, number 12. Which of the following is not an example of a physical change? Okay, so physical change is one that doesn't involve changing the matter. So we're looking for the one that's a chemical change. And don't forget, chemical change, cooking, burning, rusting, digestion. Okay, shaping gold into a ring, it's still gold. Snapping a twig into pieces, it's still a twig, it's still wood. Boiling water to form a vapor, it's still water, it just happens to be water vapor. Boiling an egg, that's cooking, you're cooking the egg, so it's D. Okay, number 13. Jesus and Maribel are trying to sort 4 types of matter into their correct classification. Whose sorting is correct? Okay, so Jesus said a soda is a homogeneous mixture. He's right. And Maribel said it's a solution. She's correct. Trail mix, heterogeneous, is correct. Oxygen is an element. Yes, that is correct. Water is H2O, so it's got 2 different types of atoms, so that makes it a compound. So Jesus is correct. Maribel is incorrect. Black coffee is a homogeneous mixture. So Jesus is the one who classified them correctly. Okay. Flora and Courtney noticed when they added 13 grams of ammonia to, and remember this had to be 13 grams of hydrogen peroxide to 63 grams of copper sulfate, a precipitate formed, a gas was produced, and the color of the solution changed. So we know we have a chemical reaction here because precipitate, a gas, and the color change. We also notice that the mass of the product, that's what happened at the end, was 89 grams. What can they determine happened as a result of the combination of the 3 substances? Okay, so we have to think about this. 63. Okay, I did this completely wrong. You guys are all going to get that one right. Here's what it should have been. That 13 grams of ammonia, and this probably should have been 14 grams, and this was 63. Okay, so if I add these together, I should get 90, right? And the mass of the product, so this is the stuff that we started with, and then we ended up with 89 grams. And that means that there's 1 gram of substance missing. And we know that when we have a chemical reaction, matter is neither gained or lost. So we don't lose mass. That's the law of conservation of mass. So if I had done this correctly, and I apologize, we should have determined that the gas that was produced would have weighed 1 gram, which would have made this 90 grams. So that would have been the answer if I had done it correctly, and I apologize. So everybody's going to get that one right.